First, note down all the given values in the problem. So here in first sentence, mass of each ball of a spring controlled governor. Actually, in this problem, whether it is Porter governor or Hartnell governor, it is not given directly, but here one sentence is present. It is a spring controlled governor. Spring controlled governor means that is a Hartnell governor. Since it is controlled by spring, it is understood that given type of governor is Hartnell governor. Mass of ball, that is small letter m, is 1.4 kg. Ball crank lever has its vertical arm 90 mm and horizontal arm 40 mm. So I already told you Hartnell governor will be having two arms, one vertical arm and one horizontal arm. This vertical arm, it's also known as ball arm, and horizontal arm, it's also known as sleeve, and sleeve arm are given. Length of vertical arm, it is 90 mm. We'll convert that into meter. You will get 0.09 meter. And length of horizontal arm, that means B value, it is 0.04 meter. The distance of fulcrum from the axis of rotation is 45 mm. So what is the meaning of that? Here, which is fulcrum point? Fulcrum point or pivot point, it's one and same. So this will be the fulcrum point, and it is given that distance of fulcrum from axis of rotation. Axis of rotation, it's nothing but spindle axis. So this radius is given, R value. So according to question, R is 45 mm. We'll convert into meter. 0.045 meter. Sleeve has a, next sentence, sleeve has a mass of 7.5 kg. That means capital letter M is given. It is 7.5 kg. Sleeve begins to rise at 220 rpm. So during Porter governor itself, I told you, when the governor begins to rise, that speed will be minimum speed. So here minimum speed is given, or N1. Minimum speed is N1 and maximum speed is N2. N1 is 220 rpm. And in the next sentence, in this sentence, it is given that rise of sleeve for 6% rise in speed is 8 mm. That means this was the initial speed or minimum speed, and when the speed rises by 6%, that will be N2 value. So you can calculate what is N2. N2 is 6% greater than N1. So N2 is given by N1 plus 6% greater. So 6% of N1, 6 by 100. 6% of N1. So you have to multiply by N1. This will be the N2 value. N1 plus 6% greater than N1. This answer you will get 233.2 rpm. So last one thing, rise of sleeve is 8 mm. So what do you mean by rise of sleeve? Rise of sleeve means, so this problem itself, if you consider ball and here sleeve will be present. When the speed increases, this sleeve will be raised. And here in this sentence, it is given that when the speed rises to 233 rpm from 220 rpm, that means 6% rise in speed, rise of sleeve is 8 mm. So rise of sleeve means from here to here. This height is 8 mm. 8 mm or 0.008 meter. So this sleeve lift or rise of sleeve, we'll write it as x. X or h you can take, up to you. X is equal to 0.008 meter. You have to find out initial thrust on the spring. Initial thrust on spring means it is S value. S1 I will tell. S1 value. And also you have to find out spring stiffness. Spring stiffness is S. You have to calculate what is S and S1, where S is spring stiffness and S1 is initial thrust on spring. S1 is initial thrust, and if they ask you to calculate final thrust, that will be S2. Initial thrust, its meaning is initial spring rate. What is the initial spring rate? So first I will calculate spring stiffness. Yes. S is given by equation 2 times A by B whole square. This equation you have to remember, 2 times A by B whole square into F2 minus F divided by R2 minus R. R2 minus R. Same equation, this equation. Rate of spring or stiffness is given by 2 times A by B whole square. You can consider either F2 minus F1 divided by R2 minus R1, or you can consider F2 minus F divided by R2 minus R. You can consider F1 and R1 also. So what is A value in this problem? A value is given directly, it is 0.09. B value is 0.04, it is given directly. F2 value. So how can you find out F2 value? F2 is given by
M omega square.
M omega 2 square into R2. F2 is given by M omega 2 square into R2, where omega 2 is equal to 2 pi n2 by 60. 2 pi n2 divided by 60. N2 value is known, N2 is 233. So you can find out what is omega. Omega 2 value you can find out. Small letter m is given in the question. Small letter m is 1.4 kg. You can keep it in kg only. But what is R2? R2 means, so this diagram if you consider, this is R2. Always minimum radius will be R or R1, maximum radius will be R2. This R1 is given in the question, R or R1 is given in the question. It is 0.045 meter. But how can you calculate R2? Just analyze this drawing. This is the initial and final position of ball arm, and this is the initial and final position of sleeve. Here given values are, this is A, this is A, this one is B, and this one is B. Final position will mark using blue color. This is final position, A and B. This radius is given in the question. From here to here it is R, but R1, R2 value you have to find out. This is R2, and this height is given. This height is given in the question. This height is, it is rise of sleeve. Rise of sleeve is 8 mm or 0.008 meter. Now somehow you have to find out R2 value. So I can make use of similar triangle equation. You have to consider two triangles. First triangle will be this one, and second triangle will be this one. Consider two similar triangles. In this triangle, this base, or in this smaller triangle, base means, we'll name the triangle A, B, this is C, D and E. So base of smaller triangle, that is AB, divide by its hypotenuse will consider, or any one side, this is B. AB divided by AC is equal to, in this larger triangle, base is ED. This will be the base of triangle. ED divided by hypotenuse is EC. Therefore, what is AB? AB value is known. It is 0.008 meter divided by, what is AC? AC is small letter b, and the value of small letter b is 0.04. AC, it's nothing but it's small letter b, and the value of small letter b is 0.04, is equal to, how can you write this ED? ED is equal to R2 minus R. You will get ED value. R2 minus R. This is not V2, this is R2. R2 minus R divided by small letter A. Now substitute all the known values. This R is given in the question. R is 0.045. You will get value of R2 as 0.063 meter. 0.063 meter. This is the value of R2. So after knowing value of R2, I can calculate F2 also. So find out what is F2. F2 using this equation, m omega 2 square into r2, where omega 2 is 2 pi n2 by 60 and n2 value is 233. N2 value is 233. Substitute all the values, you will get F2 as 52.60 Newton you will get. You can verify the answer later. 52.6 Newton. This is 52.6. 52.6. So now in this equation, I got F2 value, I got R2 value, R value is given in the question. Last one term F is pending. Calculate F. Calculate F. F is given by m omega square into R1, omega 1 square into R1, where omega is 2 pi n1 by 60, where omega 1 is equal to 2 pi n1 divided by 60. So find out omega 1 value, substitute it in F equation. We'll write the final answer. You will get F value 33.43 Newton. 33.43 Newton. Substitute this F, F2, A, B, R1, R2 in spring constant equation. After calculating, you'll get the required answer. Spring stiffness as 10,783.12 Newton meter. Newton meter. So this is the value of spring constant. Half part is complete. You can take down solution. If you have any doubt, you can interrupt in the middle. So we'll go for next calculation. Next calculation is you have to find out initial thrust also. Calculate initial thrust. Initial thrust is nothing but S1 value. So during this first slide, I told you here a spring force of W plus S1 by 2 will be acting. W plus S1 by 2 will be acting. And for this position, a centrifugal force of F1 will be acting. F1. And to calculate initial spring force S1, we have to take moment about pivot point. In every problem, you need not remember an equation to calculate S1 and S2. Instead, to find out S1 and S2, will take moment about point O. Therefore, F1 into A is equal to W plus S1 into D into B. This force into perpendicular distance A is equal to this downward force into perpendicular distance B. So I will use same principle here or same procedure. By taking moment about point C, we'll take moment about point C, pivot point. So when you take moment, force here, force F will be acting. Force into perpendicular distance A. Force, you can refer diagram in your notebook. F into A is equal to W plus S1 divided by 2 into B. Substitute all the known values. What is F1? F or F1? From the previous calculation, I'm having value of F 33.43. Value of F from the previous calculation, it is 33.43. 33.43 into value of A is 0.09 is equal to W is weight of sleeve. Weight of sleeve is 7.5 kg. Yeah, weight of sleeve is 7.5 kg. 7.5 into, but remember, in this step, when you substitute weight of sleeve, that must be Newton. So 7.5 should be multiplied with 9.81. So in all the previous step, equation is such that load should be in kg only. But here, this particular equation, it is, these equations are derived such that W should be in Newton. So convert kg to Newton plus S1, which is unknown, you have to find out initial spring force, divided by 2 into B value is 0.04. Simplify this, you will get value of S1 as 76.9 Newton. 76.9 Newton you will get. This is the final answer. After this, we'll solve one more similar problem. Then we'll wind up.
Sir, value of S, how much?
S1, right?
No,
This one.
first
Value
one.
of S1 will be 76.9 and value of S is, value of spring stiffness is 10,783.12 Newton per meter. Value of
Oh,
S, it is spring stiffness. S and S1 is different. Understand that. S1 means that is the initial thrust on spring, and S means it is a constant. The small letter S is a constant that is known as spring stiffness or spring constant or rate of spring, whereas S1 means that is initial thrust. S1 is initial thrust and S2 is final thrust. S2 we need not calculate. We'll move to one last problem. The radius of rotation of the balls of a Hartnell governor is 8 cm at minimum speed of 300 rpm. Minimum speed means it is N1, and at a minimum speed of 300 rpm, radius of rotation, that means R1 is 8 cm. Determine the speed after the sleeve is lifted by 6 cm. So this sleeve lift, that means it is X. In the previous problem we have seen sleeve lift or lift of sleeve is given, that is small letter x, it is 6 centimeter. So you have to determine the speed, that means N2 value you have to find out. Also determine initial compression of the spring. Initial compression you have to determine. Initial thrust is different, initial compression is different. Keep in mind. Initial thrust means S1. Initial thrust means S1. Spring stiffness means S, or spring constant, rate of spring. So that is small letter S. This is initial thrust. But here in the question, you have to calculate initial compression. So initial compression is given by S1 by S. That I will tell you later. That part I will tell you later. Also, you have to find out governor effort and power. The details of governor: length of the ball arm is 15 centimeter, length of sleeve arm is 10 centimeter, mass of each ball is 4 kg, and stiffness is 25,000 Newton per meter. So this stiffness or rate of spring or spring constant, it is small letter s. Note down given details first. So first sentence, radius of rotation of a Hartnell governor is 8 centimeter when the speed is minimum. Minimum speed is given by N1. N1 is 300 RPM. And when speed is minimum, radius of rotation, that is R1. R1 is 8 centimeter. Convert into meter. 8 centimeter means 0.08 meter. So first sentence is over. Determine the speed after the sleeve is lifted by 6 centimeter. So determine the speed means N2 value you have to find out. N2 value after the sleeve is lifted by sleeve lift, that is given by small letter x, that is 6 centimeter or 0.06 meter. Also determine initial compression of spring. Also determine initial compression. Then calculate governor effort and power. Initial compression you have to calculate, then you have to find out what is governor effort and governor power. And few other details are given, like length of the ball arm. Length of ball arm is small letter A, it is 15 centimeter or 0.15 meter. Length of sleeve arm. Length of sleeve arm is small letter B, it is 10 centimeter. Mass of each ball is small letter M, 4 kg. And spring stiffness is, kindly mute your video audio. Students, please mute your audio.
ಇದು ಗುಡ್ ನೈಟ್ ಗೋಲ್ಡ್ ಫ್ಲಾಶ್ ಮೋಡ್ ನಲ್ಲಿ ಫ್ಲಾಶ್ ಮೇಕರ್ಸ್ ಪೊಲೀಸರಂತೆ ಮೂಲೆ ಮೂಲೆ ಅಡಗಿರುವ ಗರಡಿಕುರ ಸೊಳ್ಳೆಗಳನ್ನು ಹುಡುಕಿ ಧಪ್ಪ ಧಪ್ಪ ಭಾರತದ ಅತ್ಯಂತ ಮಾಸುಲಿಟ್ಟುಬಿಟ್ಟಾಗ ಗುಡ್ ನೈಟ್ ಗೋಲ್ಡ್ ಫ್ಲಾಶ್.
Swastik Vinayak.
ಕಾರ್ಬೋಸ್ಟರ್ ಗ್ರಾನ್ಯೂಲ್ಸ್ ಮತ್ತು ಹುಣಸೆ ಹುಳಿ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ಸ್ ನೊಂದಿಗೆ ಇದು ಕಠಿಣ ಜಿಡ್ಡಿನ ಪದರವನ್ನು ಕತ್ತರಿಸಿ ಮಾಡುತ್ತೆ ಮತ್ತು ನೀಡುತ್ತೆ ಅದ್ಭುತ ಶೈನ್.
ಏರಿಯವು
Swastik P. Naik. So after noting down all the given values, here one last detail is spring stiffness. Spring stiffness is small letter S. Small letter S is 25,000 Newton per meter. Small letter S, it is 25,000 Newton per meter. So first, in all such problems under Hartnell governor, draw one rough diagram. A, B, here force F, initial position, this will be the initial position. I can also mark F1, A, and for this position, this will be the sleeve arm. And last one, for maximum position. For maximum position, this will be F2 and this will be B. For all the problems, better you draw this diagram. So in this diagram, or first I need to calculate, determine the speed after the sleeve is lifted by 6 centimeter. So lift of sleeve means from here to here. This is the sleeve lift. Lift of sleeve is 0.06. You have to calculate what is the final speed N2. So how can you calculate N2? Just go through all the equations. Where can you find equation for N2? Actually, there is no equation to calculate N2 directly, but this N2 term comes only in F2 equation. So if you consider F2 equation, F2 is given by m into omega 2 square into R2, where omega 2 is omega 2 is 2 pi n2 by 60. So this is the only equation to find out N2 value. So somehow, if you calculate F2 value, small letter m is given in the question. R2 value is also given. No, R2 is not given directly, but if you find out R2 value, F2 value, and small letter m, then you can calculate N2 value. So first, let me calculate R2 value. So to calculate R2, we'll use same procedure what I did in the previous problem. You have to consider two similar triangles. So let me consider two similar triangles, this one and triangle 1 and triangle 2. So from these two triangles, base is 0.06. If you need, you can name different points. A, B, C. This is D and this is E. So if required, you can name the different points of triangle. So base of smaller triangle is AB. Always you have to follow same procedure to find out R2 or R1, or sometimes if the height is also not given, if the weight of lift of sleeve is not given, again you can make use of similar triangle procedure to find out lift of sleeve. So AB divided by small letter b is equal to ED divided by small letter a. This is by using similar triangle principle, and the value of AB is given in the question. It is 0.06 sleeve lift, and value of B is 0.1 meter. Value of B is given in the question. It is 0.1 is equal to ED is equal to R2 minus R1. ED is equal to R2 minus R1 divided by small letter a is 0.15 meter. 0.15 meter. Here again R1 is given. Radius of rotation, it is given 8 centimeter. So substitute R1 is equal to 0.08 or 8 centimeter. Then you will get value of R2 as 0.17 meter you will get. Value of R2 will be 0.17 meter. Value of R will be 0.17 meter. R2. So in this question, I have calculated R2 now. M is known. So somehow you have to calculate F2 now. If I calculate F2, then only omega 2 will be unknown. So using omega 2, I can calculate N2, required thing. And to calculate this F2, let me take a moment about pivot point. Again, similar to previous problem. In previous problem also, to find out S1 value, we have taken moment about this pivot point. So even in this problem, we'll follow same procedure. To find out F1 or F2, we have to take moment about pivot point. So at this point moment is given by F1. This is for minimum position. F1 into A is equal to W plus S1 W plus S1 divided by 2 into B. This is for minimum position. Whether W1 is given in the question, weight of sleeve is not given in the question, so you can assume capital letter W as 0. Since weight of sleeve is not given in the question, assume weight of sleeve as 0, or else you can neglect the weight of sleeve. Then substitute all the known values. So when you substitute, I need F1 value. F1 is given by M omega 1 square into R1. Value of M is small letter m. Mass of each ball, it is given 4 kg. 4. Here you need not convert into Newton, keep it in kg only. Omega is given by 2 pi n1 by 60. 2 pi, what is the value of n1? N1 is given here. N1 is 300. 2 pi into 300 square. 2 pi n by 60 whole square into what is R1? Radius of rotation is 8 centimeter or 0.08 meter. You will get F1 value 315.83. You can calculate it later. You can verify it later. 83 Newton. Now substitute F1 value in above equation. Therefore, this equation will become 315.83 into value of A. Value of A is 0.15 is equal to W is 0. S1 is unknown. S1 is unknown. Divided by 2 into value of B is 0.1. Value of B is 0.1. Therefore, you will get S1 as value of S1 will be 947.49 Newton. 947.9 Newton. This will be the value of S1. So you should know one more relationship between S1 and S2 to solve this problem. The relationship between S and S1 is given by, this is important, take down this, the relationship between S1 and S2. So S2 minus S1 is equal to stiffness small letter s into x. Take down this relationship between S1 and S2. S2 minus S1 is equal to s into x. Now we calculate what is S2 value. S2 minus S1 is 947.9 is equal to S value is 25,000 into small letter x value is given in the question. Small letter x is 0.06. 0.06. By simplifying, you will get value of S2 as 2447.49. 2447.49 Newton. So why I'm doing all this calculation? Because so somehow you need to calculate F2 value. To calculate F2, first I will calculate S2. After calculating S2, one more time you have to take moment like this. So here F2 and S2 term will come. And again using this relationship, when you substitute S2, you will get a value of F2. So for that reason, I'm doing all this calculation. So we'll go for next slide. Therefore, S2 value you will get S2 value 2447.49 Newton. 49 Newton. And I just told you after calculating S2, once again you have to take moment about pivot point. Then the equation will be, instead of F1, you'll be having F2. F2 into A is equal to W plus, instead of S1, you will be having S2 divided by 2 into B. F you can W value you can neglect because sleeve weight is not given in the question. Substitute all other known values. F2 is unknown. Keep it as it is. You have to find out F2 value into A value 0.15 is equal to S2 value 2447.49 divided by 2 into B value is, I think B value is 0.1. 0.1. So by simplifying, you will get value of F2 as 815.83 Newton. This will be the value of F2. Now after calculating value of F2, you can calculate final required answer. F2 is equal to m omega square, m omega 2 square into R2. So ultimately you have to find out value of N2. For that I am using this equation. Substitute all the known values again. So 815.83 is equal to small letter m is 4 kg into omega is 2 pi n2 square, where n2 is unknown, you have to find out. This is whole square, okay, into R2. Value of R2 is 0.17. You already calculated value of R2, 0.17. Therefore, you will get the final required answer as N2 is equal to 330 RPM you will get. This is the final required answer. N2 value will be 330 RPM. There are two more sub questions. You also have to calculate what is the initial compression, governor effort and power. For this, just a one step calculation. Initial compression is given by initial compression in case of Hartnell governor is equal to S1 divided by small letter s. You have to remember these equations. S1 by s. S1 value from previous calculation, you got S1 as 947.49, and value of small letter s is given in the question. Spring stiffness, it is 25,000. Therefore, initial compression you will get 0.038 meters. This is the initial compression of spring. Next calculation, you have to find out governor effort and power. Effort is given by effort of Hartnell governor is given by S2 minus S1 divided by 2. S2 minus S1 divided by 2. S2 is 2447. S1 is 947. So by substituting these values, you will get effort as 750 RPM, 750 Newton. Unit of effort will be Newton. And last one sub question, power. So during Porter governor, I told you power is given by effort into lift. Power is given by effort into lift. This is common for both Hartnell and Porter governor. So here effort is 750. Lift is small letter x. Small letter x value was 0.06. So you'll get final answer as 45 Newton meter. So that completes entire calculation of this one. We'll quickly summarize how did we solve this problem. So you should be knowing how to construct this diagram, and also you should know how to take moment about pivot point. These two things are very important. And also you should be knowing to consider two similar triangles in this diagram. So first, in all the problems, we will use similar triangle procedure to find out unknown radius R2 value. So in all the three problems what we solved under Hartnell governor, we will make use of similar triangle principle to find out R2 value. And we will take moment about pivot point to find out initial thrust or S1 value. To calculate S1 value, we will take moment about pivot point. And in this problem, you have to use one more relationship between S2 and S1. So S2 minus S1 is given by S into X. So here S2 is unknown, small letter S is spring stiffness, and X is lift off sleeve. So all the values are given, calculate S2. After calculating S2, once again take moment about pivot point, you will get F2 value. Then using centrifugal force equation, calculate N2. And these three equations you have to remember. Initial compression is given by S1 by S. Effort is given by S2 minus S1 divided by 2. And power is given by effort into lift. So in all further problems, we will be using similar procedures. So we'll wind up now. We'll clear the screen. Hope you have taken answer. So if you